Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I'll be calculating the AC values from the Chapter 15 Math handout, problem number 19. Alright, so here we have kind of a different arrangement of a combination circuit, but it is a basic combination circuit. It is not a random unknown. And when we look at this circuit here, the way that we can tell what is in series and what is in parallel with the voltage source is by how many paths does it have for current to flow through. So when we look at R3 here, there's only one pathway for current to flow through resistor number 3. That tells us that resistor number 3 is in series with the voltage source. R1 and R2 have more than one pathway for current to flow through, so that tells us that R1 and R2 are in parallel with the voltage source. That is what determines how we're going to go about finding our total resistance. Since R3 is in series with the voltage source, I'm just going to leave him alone right now, and R1 and R2, since they're in parallel with the voltage source, I am going to take R1 and R2 and I'm going to reciprocate those two resistor values, R1 and R2. I'm going to reciprocate these two right here using my reciprocal formula to come up with a new R1/2 resistance value of 1.32 k ohms. My R3 value, I just brought him on over. I didn't do anything with him yet. So now I have 1.32 k ohms in series with 680 ohms. What do I do with resistors in series? I just combine them. So that gives me a total resistance of 2 k ohms. Alright, now that I have 2 out of 3, I can solve for IT. IT is going to be equal to VT divided by RT, so we've got 15 volts divided by 2 times 10 to the third ohms, which tells me 7.5 milliamps. If I have 7.5 milliamps total, I understand that my I3 must also be 7.5 milliamps because my I3 is on the main branch. So now I can calculate my V3 value, I3 times R3. So I take the 7.5 times 10 to the negative third times 680 ohms equals 5.1 volts. I'm going to use this equation right here. V1 and V2 will be the same amount of voltage because voltage stays the same in parallel. So V1 and V2 will have the same amount of voltage, but they can't both get 15 volts because you've already dropped 5.1 here. So when we drop 5.1 at V3, that tells us that we take the 15 volts of VT minus the V3 of 5.1 volts, and whatever that amount is how much voltage we will get for both V1 and V2 because they are in parallel. Now I can use Ohm's law. I1 is equal to V1 divided by R1, and I2 is equal to V2 divided by R2. And so I have all my values. Now I will apply my formula sheet here to find my AC values. Let me grab the steps for you real quick. Okay, so here's the RMS. Here's the steps I applied to find my RMS values. Let's run back through that real quick. So first I redrew and organized here. Reorganized to find my RT. Then I used Ohm's law to find IT, and I understand that IT and I3 are going to be the same amount because R3 is on the main branch. That allowed me to find V3 using Ohm's law. Then I determined what V1 and V2 were by using this equation here. Subtracting V3 from VT gave me the value of V1 and V2. Now I can use Ohm's law to find I1 and I2. And we're not doing power on the ACs here, so let me just magically make that disappear for you. All right. So now we need to do our AC. V2 peak. Well, right here I have my V2 RMS value of 9.9 volts. So I'm going to take, since I'm looking for peak, I take formula number 1. I take the RMS value of 9.9 volts. Nope. Yep, 9.9 volts right here. Times 1.414 equals, so my V2 peak would be 14 volts. All right, so we took our V2 9.9 volts times 1.41. We run that again, 9.9 times 1.414 equals, when we do our rounding, 14 volts. All right, the next one I'm asked for is RT, so that's my 2K ohms. And then finally, IT peak to peak, I2 peak to peak. So I look at my I2 value of 3 milliamps times 1.414 equals, since I know my answer is going to be in milliamps, I don't have to put the milliamps while I'm doing the math, as long as I put the milliamps when I'm done. So I take the 3 milliamps, which is I2 RMS, 3 milliamps times 1.414. That brings me to the I2 peak. And then when I take this number times 2, that gives me the I2 peak to peak of 8.48 volts. All right, so let's review our steps real quick. Okay, so my first step was to find RT. I understood that R1 and R2 were in parallel, so I used the reciprocal formula with R1 and R2 to find this value. And I just brought my 680 ohms over, so that gave me these two in series. I added them together to get my RT. After that, I use Ohm's law to find IT. Since R3 is on the main branch, that tells me that that current that corresponds to I3, the current of 3, since it's on the main branch, has to be the same as IT, 7.5 milliamps, because all the current has to flow through the main branch. So I found IT and I3 here and here. Now I can find V3 using Ohm's law, I3 times R3, giving me the V3 value. Then I use this equation. V1 and V2 will be the same because they're in parallel. So we take the VT minus the V3, VT minus the V3, and that gives me the value of both V1 and V2. Now I can use Ohm's law to find I1 and I2. That being my final step. Then I just applied the formulas here that I needed to find my AC values. Remember, all of these values are RMS values. So when I'm asked for V2 peak, I take the V2 value right here of 9.9 volts RMS times 1.414, and that gives me 14 volts. Resistance is resistance, so 2K ohms. Then I took the I2 RMS value of 3 milliamps times 1.414. That gave me the peak. And then to find peak to peak, I took that peak times 2. And that gave me my 8.48 milliamps.